Okay, on the same building, you see that the mechanical room is getting complicated with all the stuff that we have here, especially if you have the water-cooled chiller. If you have the air-cooled chiller, the roof will be more complicated. But here in the mechanical room, so far, we have the chiller, we have a tank, we have a boiler, and then we have the pumps and the expansion tanks. Okay, so today we will keep adding things on the mechanical room that has to be related to the hot water supply. We have cold and hot water. And here, the restrooms in these buildings are, they are here. And first, we have to explain a couple of things about the layout. So if you can see the layout here, you see that we have a double wall. Okay, so there's a wall here, another wall there, and we have a cavity here and there. And if you open the assignment, this one on piping, if you open this PowerPoint, here we have the picture of, or the floor plan of the restrooms here in this building. So you see the same. You see that we have where the toilets are, we have this double wall and we have a cavity here. And then here we have the sinks and there's another cavity there. And this cavity, it's bigger than the other cavity. This is for the drainage. Okay, so for the piping, it wouldn't be necessary, but we have to get rid of all the sheet here. And we need a space, between the wall and the following wall. Okay, because, and then it has to go all the way down because the drainage system works with gravity. And the gravity means that it has to go down. And when we have a horizontal element for the drainage system, this horizontal element needs a slope. Okay, so it can't be flat or horizontal. So we need a slope. And at the same time, that's the drawing. We not only do we need a pipe going down to get rid of all this, but we need another pipe going up the vent because we need air inlet because the air is what makes it goes down. So basically, if we didn't have this this vent that can introduce air from outside, we would have jams here, and the jam in the drainage system is something very disgusting. So it's not something that we want in our buildings. Okay, so that's why the drainage system, we have thicker pipes. We're going to deal today with the hot water supply. So we need this drainage pipe going down, but at the same time we need another drainage pipe going up. They have to be connected because we have to introduce that air here so that we don't have jams in this pipe. So at the end we have something that it will be like this. Okay, so there will be a wall here, another wall there, and we interrupt this slab because that has to go all the way down. So here we have a void so that this pipe can go all the way down. Okay, so we interrupt the slab here, and we have a double wall. And why is this? First, it's because we need an empty vertical cavity to get rid of the sheet downwards and to have the air inlet here. Okay, so this is the roof. And we need this vent from the, so we need to connect the air, the outdoor air, to the drainage system. And there is something good about this. It's about the acoustic insulation. So here we have a building And here we can have a very important meeting deciding the future of in-state college or whatever. Okay, so we can have we can hear on a meeting room. And here we have someone doing. We're supposed to do this. Okay, so even for acoustic reasons, we need to duplicate the walls here, and this is what happens in. Okay, so here we have the meeting room at the TDS building, and here we have the restroom. Okay, so we need to. We don't want to hear when we're in the meeting room. We don't want to hear someone flashing or whatever. So that's why we have the cavity. The cavity goes well because we need pipes going up and down where the toilets are, and then we need to provide more acoustic insulation. So if we duplicate the elements, if we duplicate the walls, the acoustic insulation will be much better. We don't have a single wall like this. We have a double wall where the toilets are. Okay, so if we analyze the REVIT file, here we have the toilets, we have a cavity, we don't have another room here, but if we had, that would be better duplicating the wall. Okay, so that's the explanation here. We have a cavity here for the sinks, we have another cavity here for the toilets. So let's start placing the plumbing fixtures. So you, if you select systems, you select the plumbing. And what do we have here? Here we have sinks, urinals, and water closets. We don't have showers, we don't have bathtubs, we don't have washing machines or whatever, because in this building, we don't need it. But if we did, you have to download other elements. Okay, so let's start with the toilets. So here with the toilets, we have private and public, and we have 1.6 gallons per flush. So that means that when we flush, we release 1.6 gallons, and this is greater than 1.6 gallons per flush. Does it matter? Yes, it matters. Well, when we're in a public building, I would use the greater than 1.6. So let's use this one. Okay. And now if we want to rotate it, you have to use the space bar. So if you use the space bar, you see that you can rotate this. And we have 1, 2, 3, and 4. Oh, and why do we have this? Because there is always a restroom for disabled people with wheelchairs. Okay, so when we are in public buildings, one of the places for the toilets should be bigger than others. Should be. It's recommendable that we have this for people with a wheelchair. And what is the size of that? If we have something like this, I think we need 90. Yes, 1.5. The radius of this circle should be 1.5 foot at least. We can do this in the architectural template. Okay, so we need this without any obstructions. We don't have doors here. We should have doors, but if we want to design a restroom for disabled people, we have to make sure that we have this circle, and the circle, the diameter is around 3 feet. Can be bigger. 1.5. No, it's 1.5 meters. Okay, so it's it has to be 5 feet the diameter. So it's 2 feet and 6 inches. No, now this is too big. Let me see. For which dimensions? Okay, that's it. But what's the diameter of that circle? It has to be dimensions in feet. Okay, so it's yeah, so it has to be 60 inches. How many feet do we have in 60 inches? 5. 60 inches. It's 5 foot. Yeah, makes sense. Okay, so it was 5 foot. So I was right. So this is 2 feet and 6 inches. That's the radius. So the diameter should be, if we annotate the diameter of the circle, it's 5 feet. Okay, so that's the idea. So we need probably we need to extend this wall because we need a free space, and the free space means that we don't have any fixtures, so we can move it here, whatever. Okay, so when we're designing this kind of restrooms, we have to make sure that at least one of them is bigger than others, and we need this circle with a diameter of 5 feet around it. Okay, but we are not designing the space; we're just designing the piping system. But that's the explanation of why we need one of the spaces is bigger than others. Okay, so we have this, and then let's look at the 3D view, because on the 3D view, we have to make sure that they are in the right position. So the toilets have to be on the floor, so the elevation is 0. So if we select one, they are on level 0, and the elevation from the floor level, it's 0. What's next? We can place sinks here. So we go to systems. Where is the mechanical equipment? No, sorry. In systems, plumbing fixtures. And now we have to analyze to select sinks. I have only one kind of sinks. So 1, 2, 3, 4. Okay, so we can have 4 sinks, but now if we look at the 3D view, they don't have the right elevation. So now the question, what is the elevation of a sink? 3 feet. 3 feet, but the upper part or the lower part? The upper part. Is it there or what? Okay, 3 feet, the upper part. Okay, so let's do it. So now we are on level 0, and now the elevation, if we type 3 feet, I think it doesn't work because if we go to annotate, we have to use the elevation on the east elevation here. If we annotate this distance, it's 3 feet and 8 inches. So I think they use 3 feet from the lower part. Yep, that's correct. So we have to move this down, okay? So probably this elevation, it can be 2 feet, and I think it was 4 inches. And now if we annotate this, yes, well, now it's 3 feet and 1/8, kind of. Okay. So make sure that you select all of them, and the elevation is 2 feet and 3 or 4 inches. See, 4 inches. So we have to change the elevation of the sinks, and this is 3 feet. Okay, so a table, it's not 3, or a desk, it's not 3 feet. Those are standard dimensions, and if we yeah, so the desk, it's between 29 and 30 inches. And then, well, this kind of desk, if we have something like that, this is the sink or the kitchen counter. So if we're stand up and we need a horizontal surface here, this should be 3 feet. Okay, so make sure that you internalize those dimensions, because you will save a lot of time doing these kind of things. I have internalized these dimensions in centimeters, that when I want to turn from centimeters to inches or feet, I have trouble doing that. So that's it. This is 3 feet from the top part up to the floor level. And what else do we have? Okay, we can insert, if this is the female one, we can copy this. And now in the male restroom, we will insert a couple of urinals, okay, because that's the other fixture that we have here. Systems, plumbing. Okay, and here we have the urinal with a 1-inch flush valve or 3/4 flush valve. Let's use the 1-inch, and we have this trouble. Okay, so now it works. In any of your files, you have something like that. So are you placing this in this rendition, or you don't have this issue? Okay, so I have had this issue before, because if you place on face, Revit thinks that the face in which you want to place this, it's the floor. So if you click here, and then you look at the 3D view, I don't know if you have ever used a urinal, but it's not the right position. Okay? So we found out that if we place this, we have to place on vertical face. So if we select, usually by default, it's a selected vertical face. But if it's not, you might do that. Okay, so we can place 2 of them here. And now we have to check the elevation of this. So by default, we have that elevation. And that elevation is 1 foot and 5 inches. So let's find out the height of this. It has to be from, okay, from 17 to 24 inches. Okay. So here, this is 17 inches. Okay. But let's check this, because it's important. Okay. So let's, when we place all that stuff, we have to make sure that we are working in plan. In plan, sometimes we don't notice that the elevation is wrong. So we can have this. I recommend you, once you are done with level 0, don't copy everything, because now we're going to deal with the pipes. And for the pipes, you will, okay, so when we're done with the pipes, then we can copy everything to the second floor, because yeah, I think it's better finishing everything with the pipes and the fixtures, and then when we are done with that, we copy all the stuff to the second floor. Okay, so now those are the fixtures. Now we have to analyze them. If we analyze the toilet, I'm going to analyze it in a 3D view. Okay, so what do we have here? It's something very simple. We have the water inlet, and here we have the fixture units. You remember that in this assignment, we had this table, and here with this table, we have water closets, urinals, sinks, whatever. And here we have the water fixture unit supply. Okay, so in this case, in the water closet, for a public use with this flush valve, we have 10 here. So is this consistent with REVIT? Yeah, it's consistent because this is 10 fixture units. Okay. Probably that's the only one that we have in REVIT. If we download other elements, we will find okay, we will find other elements with 6, 3, 5, but I have found one with 10. And then there was another thing on this table is the minimum branch pipe size. If we have 10 fixture units here, the minimum branch pipe size is 1 inch here. Okay, so in REVIT, this is 1 inch. Okay, so there is a consistency between the REVIT elements and the ASHRAE table. And but if we keep downloading elements in REVIT, we will find other options. But this is the option that we have here, and that's it. Okay, so we have the supply fixture units, and here we have the trap. Okay, so this is the drainage. And you see that here we have 6 fixture units for the drainage and 4 inches the size of the drainage pipe. We will talk about this next week, but well, this is what the toilet is. We only have a cold water supply. In the Middle East, they have cold and hot water supply, but because they have other habits, and there's a different story here. But in some toilets in the Emirates, they have the cold and hot water supply, but usually we only have the cold water. We don't have hot water in toilets, okay? And we don't have any hot water in urinals. If we select the urinal, we see that we have 10 fixture units. The inlet is 1 inch, and that's the drainage. It's a 2 inch. So usually always the drainage pipes for toilets are thicker than the pipes for urinals or sinks. This is 4 inches. This is 2 inches, but the cold water supply, it's 1 inch here and 1 inch there. If we go to the table, if we have urinals, we can find some urinals with 10 fixture units. And if we have 10 fixture units, we have 1 inch here for the minimum branch, the minimum pipe size. Okay, so just to make sure that we can rely on REVIT numbers. And apparently, when I uploaded these kind of elements, I selected the most, the one with the most fixture units and the biggest pipe size. But there might be other REVIT blocks or REVIT families with different values. What about the sink? And the sink is different because we have the water. This is the cold water supply, which is blue, and we have the hot water supply, the red one. We have 2.25 fixture units, and the diameter it's a ½ inch. Okay, so we use less water for sinks or for lavatories than for toilets or units. Makes sense. Okay, so that's it. Now we have to connect all these cold and hot water pipes to something that comes from the mechanical room. Okay, in this case, the mechanical room is quite far from the restrooms. That's what we have in this building. Another option, well, this is an option, but it's mandatory because I am the owner or the client, and I want you to supply water, hot and cold water, through the false ceiling and not through the floor. Okay, so from the mechanical room, we will have to go through the shaft with a hot and cold water supply, and then we have to go all this way, and we want to supply this from the false ceiling. The rule of thumb is that if we have air ducts, so I told you before, so if this is the restroom, and here we have the hallway. Okay, so we have air ducts. Then here we have hot and cold water. And here we have drainage. And electricity, usually it's at the top. Okay, so that's the rule of thumb. So if we can, we have to abide by this, because if there's a leak in the water, it doesn't affect the air. And if there's a leak in the drainage, it doesn't affect anything. Okay, so the electricity is always away from the water, if it's possible. And even the air has to be above the water level, if it's possible. And if it's not, we have to be careful with that. So we will place from the mechanical room, we will go up, and then we will go all this way, just below that level, the duct level, and then we will supply hot and cold water from there. So now, before doing anything else, before starting with the pipes, we have to think about what we want in this mechanical room. Okay, so there are different options. So the different options in the previous classroom, I was offering like different options for because now we have heating and we have hot water. So we need to heat up water, and the temperatures are different. Okay, so we have solar panels, we have a boiler, and we have a tank, and then we have the air handling unit. Okay, so the air handling unit is that we have to connect, this is what we have done in REVIT. So in REVIT, we have a boiler, we have a tank, and then we have the supply, and we have connected this to the heating coil of the air handling unit. And then we have the chiller, and the chiller is also connected to the air handling unit. But now we are dealing with hot water, the heating system, and the domestic hot water. Okay, so we have a boiler, we have a tank, we have solar collectors, and then we have the air handling unit here, the heating coil of the air handling unit there. Okay, there's an option. So the first option that we came up with is this option. So you have already done this. We have the solar collectors, we have the boiler, and we have the tank. So the tank is connected to the air handling unit. We have solar collectors connected to the tank. We have a boiler connected to the tank. If we had a tank in REVIT that had like these 2 inlets and 2 outlets, that would be a lot easier. But in the tank that we found in REVIT, it had, if you remember, it had only well, we need one supply from the municipality, so we need one cold water supply at the bottom of the tank. So in this schematic view, this is the, okay, so it's not there. I have to extend this. Okay, so at the bottom of the tank, we have the cold water supply. It comes from the municipality, so we get that water to the tank. So this is what we have here. This is the pipe that comes from the street, and then we supply cold water to that tank. Okay, so we have this fixture. This element here is inlet cold water. It's blue. So we have this cold water supply here. Then we have the closed loops. But in these closed loops, we have only 3. Okay, so we have the outlet here. And then we have this inlet. And here we have another inlet. Okay, so we have 2 inlets. We have 1 outlet. And then this outlet is for the hot water. Okay, so this is the hot water, and it's not a closed loop. So just we supply hot water to the sinks or whatever. So that would be the option here. Okay, so this is the cold water supply, and this is the hot water that is at the top of the tank, and that hot water goes to the air handling unit, to the heating coil of the air handling unit. Okay, but somehow this is connected to the solar collectors. The problem is that in that tank, here. Okay. In that tank that we have in the in REVIT, we don't have 4, 1, 2, 3, 4. We only have 3. So we had to figure out how to do it. So I'm going to move the air handling unit to this place. And I'm going to move this here, this there. Because we do need a return. Okay, so that's it. We have a solar collector. We have the tank. We need cold water supply to the tank, and then we need the hot water to the air handling unit. We have solar collectors connected to the tank, and we have a boiler connected to the tank. The problem is that in this tank we have only for the closed loops, we have only 1 outlet and 2 inlets. I'm going to make it bigger. Okay, here we have a tank. the cold water supply, the hot water, and there are 2 inlets, 1 outlet. So here we have 1 outlet and 2 inlets. Okay, this is what we have in our tank. Cold water supply, hot water from the tank, 1 outlet, 2 inlets. But the problem is that we have solar collectors, air handling units, and a boiler. Okay, so now we have an air handling unit, we have solar collectors, and we have a boiler. So if we place the air handling unit here, the solar collectors there, and the boiler there, and now we have to deal with all these elements, and each element has an inlet and an outlet. So this is what we have. Now we have to connect things, and we have to make it work, but we need to know what we have to do. So we need something that goes to the solar collectors. Okay, so I need to extend this one, and this has to go to the solar collectors. But at the same time, we have to connect this to the boiler, because in the event that we don't have enough power from the solar collectors, I will connect this to the boiler. Here. Okay. And then from the solar collectors, we need to connect this pipe to that inlet. Okay, so now imagine that only the solar collectors are working. We have to heat up water, so we get water from the tank to the solar collectors. Here the sun heat up the water, and here we have the return. So to make it different, I'm going to make these lines continuous. Okay, so we go from the tank to the solar collectors, heat up water, and then I return to the tank again. What if there is no sun? If there is no sun, what happens? If there is no sun, I have to take this water to the boiler, and then from the boiler, I have to return to the tank. So I can do this. Okay, if there is no sun, there's a valve here, so I go in this direction, and then I return in this direction, and I don't have to open the solar collectors. So if I follow the same criteria, they should be continuous, because the arrows are going this way, and everything that it's returned, we have the dashed lines. And now, what do we need? we need to get to the air handling unit. Okay, so from the air handling unit, I can do this. I can go to the air handling unit, supply, and then I can return from the air handling unit. Like this. The same criteria. This way is continuous. This way is red and dashed. Okay, so that works. I can either use the solar collectors, this loop, or I can either use the boiler, this loop. And then that heats up the tank, and then the hot water to the tank, we go to the air handling unit, and then we return it. So we are consistent because we have one outlet, two inlets. This is the inlet for cold water from the city, and this is the outlet of hot water to the air handling unit. Okay. What do we need here? Here we need other elements because there is something like this. Then sequence here. And there. Okay, so this element is what we call a three-way valve. So why a three-way valve? Because we can either go in this direction, or if we shut off this valve, then we go in that direction. Okay, so we can shut off this one, the one at the top, and then the water flow is like this. But if I shut off this one, the water flow is like that. So there are two three-way valves here. Okay, so with these two elements, I can either open the way to the solar collectors, supply, or so supply and return, or I can open the supply and return to the boiler. Okay, so this is what we have already done, kind of. So this is what we have in our mechanical room. We have something connected to the tank is connected either to the boiler or to the solar collectors, and then the tank is connected to the air handling unit. Now we have to make it more difficult, not more difficult. We have to do something else, which is we have to add fixtures. Okay, and those fixtures, we have fixtures that need only cold water, and we have fixtures that need cold and hot water. So this can be the toilet, and this can be the sink. Okay, so where do we place them? So that's the problem now. The problem now is to place things and to connect things. So I'm going to move this here. because I think I need more space for the fixtures. There. Okay. Something easy. If we need to connect the cold water comes from the city, and before getting to the tank, I can connect the cold water to the fixtures. Okay, so we already have cold water here. It doesn't have to go through the tank because the tank is to heat up water. We always need, just as a backup, we need this water pump. Here. Okay, so the water supply comes at a pressure. Remember that it was 60 pounds per square inch. Okay, so it comes at a pressure. So when we have 1 floor, 2 floors, or up to 3 floors, probably the pressure that comes from the municipality, it's enough. But if there is some issue with the pressure that comes from the city, if we have our own water pump to move the water up. Okay, but that's all we need. From this pipe in REVIT, so there's a pipe that comes from outside the building. Part of this pipe goes to the water tank, and the other part of the pipe, it will go to the fixtures. Okay, so here we have this T, and that goes to the tank. And this one, we need a water pump here. So we need to insert another pump like this, and that will go to the fixtures that are all the way here. Now the thing is, what do we do with this? Because we need hot water from this place. Okay, so the easiest way would be to go this way. Then this. Here we don't need a return because we have the drainage. So we have the hot water supply, but we don't have a return. We don't have the dashed line going from the fixture to the tank again. So does it work? Yeah. We have everything. We have hot water for the air handling unit. We have hot water and a closed loop. Good. Here we have hot water for the fixture. Perfect. We have cold water for fixtures, for toilets and for sinks. And the tank is connected to the solar collectors. If we have sun, the hot water, well, this water is not hot yet. It's getting to the solar collectors. The solar collectors, the sun, heats up the water in the solar collectors, and then it goes back to this. If it's not enough, if we don't have enough energy from the solar collectors, we need to use the boiler. So we use the boiler, we heat up the water, and that's it. So apparently, this system works. The problem is that when we need to deal with different temperatures. When we need to deal with different temperatures, and what do I mean? What is the temperature for the hot water supply? $140. Okay, 140 Fahrenheit. In international units, I think it's 60 Celsius. Yeah, 60. Okay, 60 Celsius or 140 Fahrenheit, it's something dangerous. Okay, so we can't, human beings, we can't cope with 140 Fahrenheit. So why do we need, so if you open the hot water in the bathtub or in a shower, after a few seconds, you get burned, okay? So you can't cope, you can't stay for 1 minute under 140 Fahrenheit because it's dangerous. So why do we need this? Because we have to kill the famous Legionella, whatever. This is the bacteria. Okay, so this bacteria, this Legionella, grows from 77 Fahrenheit to 113 Fahrenheit. So those are temperatures that we can cope with. Around 100 Fahrenheit, that would be a good temperature if we are having a warm shower. But that temperature is perfect for this bacteria. So we have to kill the bacteria and then we can get the water at this temperature. So we have to heat up this up to 140. We kill the bacteria and then we mix this to the cold water. What is the cold water supply? The cold water supply in winter, it can be around 40 Fahrenheit, something like that. It comes underground, so that's why it's not frozen, because it comes from the underground. But we can have 40 Fahrenheit. Okay, so what we get from the cold water supply is 40 Fahrenheit. We mix 40 and 140. And we end up having 80, 90, something that it's good for us. Okay. What's the problem? The problem is that for the air handling unit, the temperature, we hardly ever need 140. Probably we need around 90 Fahrenheit for the air handling unit. Okay, so here we have an issue. We have an issue because we have this at 90 Fahrenheit. But the water in the tank, it has to be at 140 because we have to kill that bloody bacteria. Okay. So how can we deal with this? Because 140 can damage the heating coil of the air handling unit. So we cannot supply water at that temperature. So we have to do something like this. Okay. So we supply this temperature. It can be at 90. I'm going to is continue. Okay, so that's the heating coil of the air handling unit. In REVIT, we have the coil here. So we have something here at the top and something at the bottom, supply and return. So this is what we have here. So we supply this and then we return this to the tank. But the problem is this, that we can't supply this. So we need 90 Fahrenheit here, 90, 85 or 92, whatever, but we don't need 140. But after heating up the air, probably the temperature here is around 50. Okay, so that's why we have to return this water to the tank, because we have to heat it up from 50 to 90 again. Well, what happens here is that we can have another branch like this. And like this. So we recirculate this water. So that water that comes at 140, it goes this way, and we mix up this water with some water that comes at 50. So we will need another three-way valve here. Okay. So that's key for if we want to understand how that works. We have water supply 140. It's good for the fixtures. It's good for the sink. We have here the bacteria, and here we have this cold water, and we mix this, and we end up having the temperature here that we can have in the shower. It can be around 80. It's good for a warm shower or whatever. Okay, so we mix this 140 with 40, and we have this here. What about the temperature in the air handling unit? The temperature in the air handling unit, it can't be 140. It's too hot, but it has to be around 90. So we warm up the air. Here we can have another arrow for the air. Okay, so this is air, and the air outdoors can be 30 Fahrenheit. Okay, so the air goes through the air handling unit, and we heat up this air up to 70 Fahrenheit. This is what we need for the indoor temperature. So that air, it's not blue anymore. It's yeah. So we have air at comfort temperature. So we have heated up the air from 30 to 50. And then we have lost the energy that this water had from 90 to 50. Okay, so now we have this other branch. And here, if we have 140, we can mix this 140 with this water at 50, and we end up having the temperature that we need in the air handling unit. Okay, so that will solve all our issues. But now we need to understand what we are doing. Okay, we have already done this. We have connected the solar collectors, we have the boiler, we have the tank, and we have the air handling unit. But now from the air handling unit, we should have another branch. So at some point, we have to mix the supply and the return from the air handling unit. But at the same time, we need a free way from the tank to the fixture. Okay, so things are getting complicated. And does it affect the architecture? Well, we need to know how many elements we need. We need the air handling unit. It's a monster that is on the roof. We need solar collectors. They are on the roof. We need a boiler. Usually they are in the mechanical room. The tank is usually in the mechanical room. So it's quite easy to connect the boiler to the tank But the solar collectors, they are on the roof. We have to connect them to the mechanical room, the air handling unit as well. And then we have all these three-way valves. And without those three-way valves, the system doesn't work. Okay. So the key to a good performance of this system is that these three-way valves do what they have to do. And what do they have to do? Do they think? No, valves don't think. I don't think so. So who's thinking here? So who's the master? There are engineers deciding all these kind of things. And we need to know what they have decided, because then we have to place things, and well, then the plumber connects everything. Yeah, okay, so we are not we're not plumbers, we're not dealing with, we're not doing that. But we need to know what we're doing, because we are placing elements, and when we are working with REVIT, we have to connect all these pipes here. Okay, so before doing this, connecting pipes, it's quite easy. The difficult thing is to understand what we have to connect with what. Okay, so that's feasible. The thing is that we need all these three-way valves because this system has to make decisions. When the temperature from the solar collectors is not 140, then we need the boiler. When the temperature here is 140, we don't need the boiler. Then here, with the temperature, when we are using the heating system, the air handling unit, the temperature in the air handling unit, the inlet has to be 90. If it has to be 90 and we are supplying 140, then we need to mix the water with this return at 50. And if we don't need this, we supply this, and when we return it again, and we do this. Okay, so each time, all these three-way valves, they have a lot of sensors. And okay, if the temperature at the top of the tank is that, I open this way. If it's something else, then I open a different way. So that's why these three-way valves are essential to understand what we're doing here. Okay. So when we were doing this in the first section, there were different options, because here the elements are solar collectors, boilers, a tank, and air handling units. Perfect. But probably the pipes are more complicated. If we want to simplify the pipes, but if we want to simplify the pipes, probably I will have to add something else. So what is this option? This option in terms of here. In terms of simplicity of pipes, that option might be the easiest one, because I separate the systems. I have something for heating, and I have something different for the hot water. And here we have an electric water heater. If you visited the mechanical room, you know that we have electric water heaters here. This is the option that I would use, because in a building like this, in a commercial building in New England, the heating loads are the important ones. The hot water loads, it's not that much. How much hot water do we have in this building? We have a few sinks over there, and we are not using those sinks constantly. Okay, so the amount of energy that we need to heat up the water that we have in the sinks, it's not an issue. So that's why I would do this. I would use a water heater, an electric water heater. I don't connect this water heater to solar collectors, to boilers, whatever. Okay, so if I need to heat up some water, I heat up this 140, and then I'm using this for the rest of the day. Okay, but we need a cold water supply for the water heater, and we need a cold water supply for the tank. And then this tank is connected to solar collectors, it's connected to the boiler, and this tank is connected to the air handling unit. Okay, so we have this is what we have already done. And if we want to insert something new, that would be the option. We have a water heater, and with the water heater, it will supply domestic hot water to the fixtures. Okay, so when we don't have a lot of hot water demand, I would use this. In a commercial building, in a building with classrooms, I would do this. If we were using or if we were designing a hotel, in a hotel, we have heating and we have a lot of hot water because we have rooms, people take showers. So I would do something different. I would try to do this. So what's this? So that would be the most expensive option that we might have. Okay, we are duplicating everything. We have a tank, a boiler, and solar panels for the air handling unit, and we have a tank, a boiler, and solar panels for the domestic hot water. It's quite expensive in terms of equipment because I'm duplicating everything. Okay, so in this option here, we only have one air handling unit, one boiler, one tank, and one set of solar collectors. In this option, I have two sets of solar collectors, two boilers, two tanks, and one air handling unit. But I have a system, a very efficient system for the hot water, and I have a very efficient system for the air handling unit. And the pipes are easier to understand because I don't have to connect the return with the supply, a three-way valve. No, here we don't have any three-way valves. It's pretty straightforward. We need a tank. This tank is connected to a boiler, and it's connected to the solar panels. If we have enough energy from the sun, this set of solar panels heat up this up to 140. This set of solar panels heat up this tank up to 90. So the temperatures are different. And if we don't have enough sun, I can have a boiler, and I can have another boiler here. Can we simplify this a little? I think so. I think we can get by with just one boiler. If we had a boiler here, and that boiler could supply okay. If we had only one boiler and that boiler, okay, do we need to at this arrow? No, it should be like this. Okay, so we have only one boiler. We have two sets of solar panels. If the solar panels are not working and I need to heat up this tank, the boiler can heat up this tank. If these solar panels are not working and the boiler has to heat up this tank, then we can heat up this tank. Okay, so that's option. This option is more expensive, it's more flexible because we have independent systems for heating and for hot water. This option, we are sharing only the boiler. And I think this is what I would do if we were designing a hotel or a building in which the heating system is very important. and the hot water is very important. I have two different sets of solar panels connected to two different tanks because we need two different temperatures. We need 140 for the hot water. We need 90 for the heating system. So we have solar panels. If there's something wrong with the solar panels, I have a backup boiler, and this boiler can heat up this tank and can heat up the other tank. Okay, so first option. This is what we have in REVIT. I'm not adding any other equipment. I'm just using solar collectors, air handling unit, a boiler, and a tank. So I'm not adding any other equipment. Second option, I separate things. I have what I have for the heating system, the air handling unit, solar collectors, a boiler, and a tank. And I have something independent. It's a water heater for the hot water. Okay. If in buildings with very low demand of hot water and very high demand of heating, this is what I would do, and it would be the most simple option. Yes, so it could be more effective because I need electricity to heat up water, but there is so that we don't have in buildings like this. Hot water is it's almost nothing. Now I have everything under control. I have two different systems: solar panels, boilers, and tanks for hot water, and solar panels, boilers, and tanks for heating. Perfect. Now, okay, let's share the boiler. Okay, so we have solar panels for this tank, solar panels for that tank, and we share the boiler. I think this is better than this option. Makes more sense, this one, than this one. But we have more options. So what are other options here? This option doesn't work. What do we have here? Okay, so we can have solar collectors connected to the water heater. Okay, but that water heater has a backup, which is an electric engine. So if we don't have any sun, we can run electricity for the water heater, but the systems are different. So this option and this option are quite similar. Okay, the only thing is that this water heater allows me to connect solar collectors. I save some energy because the solar collectors can heat up this tank for free. If we don't have enough sun, I run the electricity. With this option, I always depend on electricity. Okay, but those options are quite similar. What about this one? Oh no, this is option one. Yes. And is this anything different? Okay, so here we have two tanks. I have a tank for at 140 for the fixture, for the hot water. I have a tank at 90 for the air handling unit. And I share the solar panels and the boilers. Well, I use the solar panels only for the domestic hot water tank, and I share the boiler for two tanks. This is what we would do in Spain, because in Spain, those kind of solar collectors are only mandatory for domestic hot water. We don't use this for the heating, because in Spain, heating is not as important as here. We don't have this nasty weather. So we can save energy in residential buildings with solar panels, but only for the domestic hot water. We don't connect solar panels to the heating system. We have a boiler, and then the boiler is shared with this tank and that tank. Okay, but there are different options, and now we have to decide what option we want to use. I'm going to explain this one because in terms of Revit, that's the easiest. But if you want to go for something more advanced, you can go ahead. Okay? And there will be different grades for different options. So that's the easiest. And it's not bad, believe me. Okay? Probably this is more flexible. So that would be the option with more grades or more points, because you have to duplicate systems and you have to figure out how to connect everything. Okay? But that option works well with our system, and it's very easy. So let's come here. Here we have the boiler, we have the tank. What we need now is an electric heater. So in systems, we have mechanical equipment. And here, at the end of these elements, we have the water heater. We have 40 gallons, 50 gallons, 75 gallons, or 100 gallons. So how many gallons of hot water do we need in a building like this? Probably 40 gallons would be enough. If we don't have showers, we don't need a huge tank. So 40 can be good. So I'm going to place this on the mechanical rooms. Make sure that it's on level -15 and the elevation is 0. Oh, it's on level 0. Okay, so we have a water heater. Let's analyze the water heater. Well, it's quite simple because we have the electricity here, and we have the outlet. So this is a drainage. Okay, so this water heater, it has the inlet here at the top and the outlet at the top. Okay, so if we want to connect this to the water supply that comes from the city, I just have to right click, draw pipe. I change that elevation to, let's say, 5 feet and 2 inches. Okay, so I have to go up, then I have to move in this direction. And then I only have to connect this pipe to this pipe. If I do it from the top view, Revit does it automatically. Okay. So now I have connected the cold water supply to the tank and to the water heater. And now this water heater, I have to connect the hot water supply. So I can throw pipe. I can change the elevation to, let's say, 10. And then I have to move to the shaft. Right. Okay, so I have this shaft that is becoming quite busy. Then I continue the pipe. And here I have to go up. I have to go up to the ceiling of the second floor. So I have to change the elevation probably to 14. And then I have to continue horizontally. Let me see what I have done. Okay, that goes well. We are below the duct level. Okay. And now I need another horizontal pipe because that goes to the second floor, and I need to copy and drag it to the first floor. And here I need a T. There you go. Okay, so from this vertical pipe that goes through the shaft, I have a branch that goes to the first floor and another branch that goes to the second floor. Then I have to go all the way to the restroom. Okay, here we are. And now I need to see that. Okay, it's here. So I can go, I have to make sure that I am within that cavity. That's why I wanted to analyze this, because I want to be within this cavity, but I don't see that pipe in this view. Anyway, I think we're pretty close to it. And now I have to throw pipe all the way here. So I'm starting always for the farthest. So the okay. So I have selected the inlet of cold water here, and I just have connected this to this horizontal pipe. Okay. And now we should do the same with the rest of the elements, sinks. Throw pipe here, and REVIT does it automatically. Okay, so now you have to keep doing this with all the sinks. What about the urinals and the toilets? Here we have an elbow, so we have to lift this elbow. We have to extend this pipe in this direction. If we extend this, there will be a T. Okay. And now I can do the same. I can drag this here, make sure that I'm within the cavity, and then I have to go to the farthest element. And from this one, I draw pipe here. And there. And now you can keep doing the same thing with all the elements. Well, before doing that, okay, we can keep going. But now you have to remember that there were rules of thumb in terms of the thickness of the pipes. So what was the rule of thumb? It's on this lesson. Here. Okay, up to three 3.5-inch branches can be served by a 3/4 main branch, and up to 10 1-inch branch, it can be served by a 1/4 inch. Okay, so now we have to analyze this. Here we have this is 1/2 inch. Half or 1? Well, it should be 1/2 inch because the diameter is 1/2 inch here. Okay. But how many of them we have? We have 1, 2, 3, 4. So up to 3 1/2 branches, we can use the 3/4. So these should be at least 3/4. So we have 1, 2, 3, 4, 5, 6, 7, 8. And the rule of thumb says that up to 10 1/2-inch branches can be served by 1/4 inch main. So what I would do is to connect this one here. And I will make this 1/4. Okay. Now, this is 3/4. Here we have 1, 2, 3, 4, 5. No, probably the best option, the simple option would be to, if we make the decision that this is 1/4, then extend this up to the end. Okay, if we want to save some money but we want to complicate the plumber's life, we can connect all these to the 1/4. And then after that, we have 4. So this doesn't have to be 1/4. This can be just 1 inch. And then we connect this to all the 1 inch. Pipes here. Okay, so those are minimum requirements. So the minimum, if we have 10, the minimum would be 1/4. Okay. But if we have 8, I can say that, okay, for 8, it works. I have 1/4 too. Then here, okay, if we have only 4, well, maybe this can be just 1 inch. What is it? Yeah, so this is 1 inch. It doesn't have to be 1/4 because there's only 4 left. Even this could be 3/4. No, because 3/4 is only up to 3. Yeah. Okay, we have 4 there. So I would do this 1 instead of 3/4. With this branch, it's something different because here from the toilets, we have something that it's 1 inch. Okay, so if we have a 1 inch branch, we can't have a 3/4 here. Okay, so that would be wrong. So in this branch, we have a lot of things. Okay, what does the rule of thumb say? Okay, so if we have here 1, 2, 3, 4, 1 inch pipes. What we can take for granted is that this one has to be more than 1 inch. Okay, so I can make this 1/4 or where is, or 1/2. Okay, so if we have this 1/2, then I can connect it here and here. And here. So now this is my decision. If I move this way, I have 1, 2, 3, 4, 5, 6, 7, 8 fixtures connected to the main branch. So at the end, that main branch would be too thick. So I'm going to branch out here in this direction. And I'm going to copy this one here. So if this is 1/1/2, this has to be at least 1/1/2. So I make this 1 3/4. It's 1. Work. That's 2 inch. Oh, because I don't have, okay, I have 1, 1/1/2, 2. Okay, let's make it 2 inches. And then from this one, and now the rest of the pipes here should be 2 inches. Okay, so we see we can't, if we connect different things, we can get narrower. So this has to be the biggest one, has to be the main branch here. And then if we branch out here, that can be smaller. And instead of going here and connect 1, 2, 3, 4, 5, I think that option will work better. If we go this, and then we have this branch here, that branch there. But yeah, there are different options. So I don't mean that this is the best one, but the rule of, it's something wrong if we have here 1 inch and suddenly we have 3/4, that would be wrong. So if we have a half, when we have 3 or 4 half inch, then this branch has to be bigger. If we keep adding things, this branch has to be thicker. This is the hot water, sorry, the cold water. The hot water is, no, this is hot, sorry, because it comes from the water heater. I think I made a mistake. Yeah, so that's wrong. If I'm dealing with the hot water, I should connect the hot water inlet to the hot water pipe. Okay, so I did it wrong, but I'm not going to fix it. Because I made a mistake. We are dealing with this. Okay, so we do not connect the cold water, but the hot water. Okay, so that's what we. Okay, so we made a mistake. We have to connect this to the hot water pipes, not to the cold water ones.